So one of the problems we have with arrays is that their size is fixed once we've created them. And in reality, we need to often add things to collections, and we don't necessarily know the size at the start. Now, we might think, well, we can get away with arrays by making them much larger than we need, and we could do that. But that poses another problem in that if we start putting things in our array and we want to put something between two items that already exist, we've got to shift them around. So it's not the most convenient structure for storing data. So that's where other types of data, in particular lists in Java, become useful. So we're going to look at a particular type of list, and in fact you'll find that the things that we use for this type of list are very similar to other types of list in Java. But the type of list we're going to look at today is something called an array list. So an array list is like an array in that we can store items of the same type together. But the syntax for creating it is a little different. We don't have array literals in the same way we have with arrays. There are other ways of getting things into our array lists, but what we can do is we can add items to the list, we can take items out of the list, we can even see if the list contains certain things. So we create an array list. The type for an array list is ArrayList. But what is slightly different about this is that the items we store, the element inside our array list, also has a type. So we can have an array list of, for example, strings, but it's also possible to have an array list of integers or an array list of doubles. Okay. What is slightly different though is we can't have array lists of the primitive type. So I can't have an array list of int. I have to use the class type, the integer type, to store integers if I want to. We'll use strings for now, but I'll show you how to create an array list of integers should you need to. So an array list of strings would look like this. So we put between angular brackets the type, okay? So this is an array list of string. If we were going to create an array list of integers, we'd say array list integer. I haven't imported array list, so I'm just going to import the class there. You can see it's added an import statement. Similarly, if we wanted double, again, we've got to use the class type. We can't use the primitive type. It won't let me use int. It says type argument cannot be a primitive type. It suggests using integer instead. Okay, as I say, we're going to use strings. So that's a bit like the equivalent of doing, if we were doing a regular array, it'd be like saying string. Okay, but this is an array list. The use of this is, so an array list is what's called a generic type, because we can use the array list type with all sorts of different objects. Theoretically, we could have an array list of scanners if we wanted to. In this case, I say we can use string. Like always, we give it a variable name. So if we were just collecting names of people, we might call it names. Okay, and then we create a new array list by using equals, and then we say new array list. Okay. We're not obligated to specify the type this side of the assignment, okay, because it's here and it can figure it out. But while we're learning, it probably is easier to put it in both sides just so we get familiar with it, okay. And then we have an open and close brackets. Now, because an array list can change its size, we're not obligated to determine how big the array list will be when we start. But if we know that it's got to be at least a certain size, and particularly if it's going to be particularly large, we know we're talking sort of hundreds of records, we can specify sort of minimum anticipated size in here. So if I knew, for example, I was going to store 500 names at least, I could create an array that would have space for at least 500. But that's not a requirement, and we can take that out for now. We're only going to be storing a small amount of names, so it doesn't really matter. Okay, so how do we go about putting things into our array and getting them out? Well, we can type the name of our array. We don't use the square bracket the square bracket option. Okay, instead, if we want to add something to the end of the array, we can do .add. Okay, so if I want to put my name into the array, I can do that, and then I pass into the method the thing I want to add. Now it's important that this type matches this type. So what I can't do is names.add 4 or 3 or whatever. Okay, it's going to complain and it's going to say required type string, provided type int. Okay, so I can only put that in there. So we can add another name. Maybe we put Ralph in there. And what it will do, each one of these will be appended to the end of the array. So let's add another one. We'll put Helen in there. And let's add Lily as well. So now our array list, has 4 items in it. And just like string, array is actually a class, and it has methods that we can call. So for example, if we wanted to know whether or not the array list contains a particular name, we can ask it. So we can say something like if names dot contains, okay, and we can pass in, let's see if we want to say, does it contain Lee? Okay, and if it does, we could print out Lee is in the list. Just to prove it's working, we'll do a Lee is not in the list. So if we run that, we should be able to see that Lee is not in the list. Okay, so that's a nice quick way of finding out if something is inside the list. One thing we can do with arrays is look at the value in a given position. So if we want to find out what, for example, the second item in our array is, we could say something like string second name equals names. And again, we don't do this. So this, if we try and do this, we'll get a complaint. Okay, it's going to say array type expected found array list. So basically it's saying you're trying to treat this as an array, but it's not an array. Okay, so instead we do .get and we pass in the index we want. So again, it's 0 based. So Andrew will be at 0, Ralph will be at 1, Helen at 2, and Lily at 3. So if I was to print out the second name, I should see that Ralph's name is printed out. There we go. So that allows us to get, so we can add things, we can get them out with get. Now obviously in an array we can say, well, I want something at a particular position to have a particular value. And we can do that as well with an array list, okay? It gets a little bit more complicated because we actually have to pass 2 parameters to the method. But let's say I want to add another name. So I can do is it insert? No, it's set. I guessed insert because other languages use insert, but Java uses set. And you can see it's asking for an index and an element. Okay, so let's try that. Let's set at position let's go for 2. So it'll put it in after Ralph and before Helen. And the thing we want to put in, let's put in, did we say we're going to put in Graham? Okay. So now we should see, if I was to write a loop to loop through all of the names, we should be able to see those lists, those in order. So let's try that. We could say for, and we could use one of the for each loops. Again, we use this just like we would with a regular array. So we could say string name in names, and we could print out the name. And let's run that. And all being well, we should see Graham has been added in between Ralph and Helen. There we go. Andrew, Ralph, Graham, and Lily. Andrew, Ralph. Except we're not inserting it though, are we? We are. I said to put it in. We haven't put it in. We've replaced. We're essentially changing like we would with an array. We're changing now. Do we have? The next question is, do we have an insert? I'm not sure whether we do. we have a contains. We can use add, right. So this is the difference. We can use add again, and we can specify an index and an element. So with set, we replace. So this will replace Helen with Graham. But if we use add, we can specify the position. Okay, so let's say we want to add index 1, and we want to add Janet into the list. We should now see that Janet is added between Andrew and Ralph. So let's run that. So Janet has been added between Andrew and Ralph, okay, and Helen was replaced with Graham. Again, we could comment that out just to show that, leave Helen in to make it clearer. There we go. So Janet is now added between Andrew and Ralph there. Let's just get rid of that for now. Okay, so that's add, and we've done set, we've done get. Okay, we might also want to remove things from our collection. So let's just get rid of those for now. So let's say we don't want Ralph in our list. We can do names dot remove. Now the important thing here is there's two versions of remove that we can use. We can use remove and pass in an object, okay? And actually, in reality, we need to pass in a string. We're passing in something typically, and for all intents and purposes, what we're doing now, the type of the array. So we could say remove, and we could pass in, say, Helen. Okay, and then if we just put that for loop back in, so for string name in names, and we run this name, I'm going to print out the name. We should now see that it's just Andrew, Ralph, and Lily. There we go. Okay, but we've also got a version where we can pass in an integer, okay, or specifically an int. And if we use this version, we pass in the index of the item we want to remove. So if we want to remove Andrew from this list and run it, we pass 0, it will remove the item at position 0. And now the list should just have Ralph, Helen, and Lily in it. Okay. I guess one final thing is that when we have arrays, we use length to find out how long they are. That's different with ArrayList. Okay, so if we wanted to find out how long ArrayList is, we could say something like int length equals, and in this case it's the size, and again it's a method. So we can say that, and we could print out ArrayList has ArrayList has plus length plus items. We could use names.size here instead of putting in a variable called length. I'm just trying to keep it simple for now. Okay, so that's an introduction to ArrayLists. I think I'll just show you one other thing. Let's say we wanted to keep a list of marks, so we might do an ArrayList, and marks, assuming marks are integers, we would need to store them like that, and we could say marks.
Sorry.
Oops, and Siri is going crazy while we do that. Let's turn Siri off. And then we could say that's a new array list. Again, we don't have to specify the type, but while we're learning, it might be helpful. Then we don't have to remember which one it has to go in, because it has to go in the left side. Otherwise, we end up with all sorts of potential issues where we don't know what type of thing is stored in the array. It will work, you know, if we take this out, it will should let us use it. And we could add a number to it, okay? But if we wanted to, you check if it contains something. Well, actually, that's probably not the best idea. If we do, say, for example, marks dot add, it doesn't know what type. It's saying like add object, okay? Whereas integer, and now it knows that we need to add an integer. So it's a good idea to specify the type. The only reason we wouldn't want the type is if we were trying to write something that would work for any array list where it didn't actually matter what the type is. Okay, so let's just add another, let's make these marks a bit better. Let's make that one a borderline pass. Let's make that a first class mark. And let's just add another couple. Let's add, I don't know, 56. And we'll pop in a very good mark as well of, say, 87. Okay. So just one thing to watch out for. We've created this as an array list of integers. Okay, it's just warning us that we're not using it at the moment. And as I said, good practice to get into, or at least while we're learning, to pop it in there as well. Now this is where things get confusing, because if we remove, in fact, let's just make this a little bit more complicated. Let's set a mark of 1 there, okay? And then we say marks.remove. Now you'll see here, we've got the option to remove an int or an object, okay? So if I do remove and just pass in 1, we might want to think about what is it going to remove, okay? And why is it going to remove the thing it removes? So let's just quickly show which one is removed. Integer I in marks. In fact, mark is probably better. Variable name, and we'll just print out the marks. Okay, so let's see which one it removes, okay? Because you might think, well, this has got an index of 0, this has got an index of 1, this has got an index of 2, it's got an index of 3. So will it remove the index or will it remove the value, okay? And the answer is it's going to remove the index. It should do. There we go, 41 and 87. And the question is why, okay? Well, if we look carefully at the remove method, you can see you can remove an integer, which is a primitive type, or an object. So anything that is an instance of a class, anything that is an integer or a string or the double with a capital D, anything that's not declared with a lowercase. So we've got a lowercase in num equals 3. The type here, this is a primitive because it starts with a lowercase. Anywhere the type does not start with a lowercase, we're looking at an object rather than a primitive. Okay, so when we pass in this value of 1, we're passing in the primitive type. Okay, we're passing in the int. Okay, if I want to, and therefore treat it as the index, which is why this one's removed. If I want to remove an object, if I want it to look and see if there's an object that matches a 1, I actually need to create an integer with that value. And you can create a new integer with a value like that. Now I think it's probably telling me that it would prefer me to do something like integer dot value of and pass in a 1. But actually, to simplify things, we can actually do this. Integer value to remove equals 1. Okay, and if I type it, if I do value to remove, we know that this is going in as an integer, and instead of removing the index, it should remove the integer. So let's run that and have a look. There we go, it has removed this one. Okay, so if you're looking for the thing to remove, it's got to be declared as an object. So here we've got to have a type that is not a primitive. If we want to remove an index, we can just provide the index. So just as an example, if we say int index to remove and pass that one in instead, because that is an int, it will remove this one like we had the first time round. There you go, you can see it's taken the 70 out. Okay, so that's just something to watch out for. As I say, we can create an array list of any given type as long as it's not a primitive, and we can add items, we can check if it contains an item, we can get items at a particular index, we can remove items, we can set the item at a position, and we can find out the size of an array list.